Hello, myself wbjee. In this class, I will try to discuss in a nutshell the concept of function, which are actually included in the wbjee syllabus. So, what is function? Let's take two sets A and B. Then f is a function from A to B. If f maps if f maps each element of each element x belongs to a definite element y in B. What it actually means? It actually means that no element will have two defined images in the codomain. That is, this cannot happen in a function. So let's discuss the two different type of functions. First, we will learn what is injective function. So injective function means that if f is a function from A to B, then if we take two elements x1, x2 from the domain A, and if x1 not equals to x2, then their images will also be unequal. And if we consider the contrapositive argument, if fx1 equals to fx2, then their pre-images will also be equal. So if we are given with two sets having n elements in the domain and m elements in the codomain, we will try to find how many injective functions will be there between A and B. Let's say the cardinality of A, B, n. Cardinality means the number of elements in a set, and the cardinality of E, B, n. So we will try to find number of injective functions from A to B. So these elements have n possible ways. So the first element in A will have n possible ways, and then the second element will have n minus 1 possible ways. In this way, the last element will have n minus n plus 1 possible ways, and this is actually equals to npn. And if we write with the help of the binomial coefficient, this is ncn into n factorial. So now we will discuss what is the onto function. Okay. And injective function actually has another name, it is called one-to-one function. So we will now discuss what is surjective function. We will now try to understand what is surjective function. So surjective function is defined as follows. It says that if f is a mapping from A to B, for each element y belongs to B, there should exist an element x belongs to A such that fx equals to y. That means the rule should capture the whole codomain set. If any element in the codomain if f misses any of the codomain element, then f will not be a surjective function. In that case, we will call it a onto function. Like this, suppose that domain has 4 elements and the codomain has say 3 elements, and say f is a rule like this, then f will not be a onto function. Surjective has another name, onto. Then f will be an into function, because codomain has an extra element which has no pre-images. So now we calculate how many surjective functions can be formed between two sets. So first we will take a small example, short example, then we will discuss a general case. let's say the domain has 4 elements and codomain has 2 elements. Then let's say the codomain has 4 elements and domain has 2 elements. Then obviously these elements has 2 possible ways, this has 2 possible ways, this has 2, this has 2, therefore number of all possible functions to the power 4. And in those cases, when f will not be an onto function are actually these 2 cases, when all these elements are mapped into this element and when all these elements are mapped into the second element. So these are the 2 cases in all these 2 to the power 4 cases when f will not be onto function. Therefore we should have to minus 2 from here and it will give you the total number of surjective function, which is actually 40. So now we discuss for the general case, if say it has n number of elements and it has r number of elements. So what will be the total number of surjective function? And actually this is calculated using the inclusion exclusion principle. So if now we discuss a general case. So if the domain has n element and the codomain has r number of elements, then total number of surjective function will be r to the power n, all possible functions. Then we are excluding those functions which have misses the one element. Then we are adding those functions what we have actually subtracted twice. Then we are actually including these this counting where 3 objects have missed in the codomain, and like this will be continued up to this subtraction is positive, and this is the total number of onto functions. And obviously this holds if r is greater than n, because r should be greater than n, this will hold. If r equals to n, the number will be r factorial, and if r less than n, then there will be no surjective function. So now we will discuss the composition of 2 functions. So for composition we have to take 2 functions, say f a to b and g b to c. We have taken 2 functions. Then we first compute the composition GOF. So GOF is defined. First we have to take x from a to b. This is the set A, and g from b to c. So x is taking this element from a to the set fx, and then g is taking fx to g of fx, and we will call this as g of fx. But the fork, that is the f composition g, will not be defined in this way. This has some restrictions. So if we now try to compose f and g, first compose f and then compose g, this has some restrictions under which f compose g will be defined. So first we have to take g. So g is from b to c. Now an element in x is taking that element onto c. So this is gx. Now see that the domain of f is a and the codomain of g is c. So if f act on gx, then this codomain of g should be a subset of the domain of f, because otherwise f cannot act on this element. That element should include in the domain of the g. Therefore, if domain of g is a superset of codomain of g, then only in this case f will act on this element. So the restriction, if we write it clearly, the the codomain of, or we say that the range of G, it's actually range, not codomain. Range of G should be a subset of domain of F, and in this case, F of G will be defined. So let's take an example to understand it clearly. Let's take Fx equal to, let's say Fx equals to tan x. X belongs to minus pi by 2 to pi by 2 open interval, and gx equals to root over 1 minus x. So if we consider this domain, we can clearly see that f is a function from minus pi by 2 to pi by 2, from minus infinity to infinity. It is very clear because tan goes to infinity and minus infinity at pi by 2 minus pi by 2, and gx will be defined if x belongs to minus 1 to 1, and clearly the range of gx will be 0 to 1. So g is defined from closed interval minus 1 to 1 to closed interval 0 1. Now if we try to compose FOG and GOF. So first FOGX. So FOGX will be f of gx. Now see that the codomain, the range of G is 0 1, and 0 1 is a subset of the range of the domain of F. Therefore, it will be defined. Therefore, it will be clearly defined because F can act on this element. But if we take GOF, see that if we take GOF, then this is G of Fx, and what is the value of Fx lies between minus infinity to infinity, and that element should belong to the domain of G, but the domain of G is minus 1 to 1. Therefore, it lies up. Therefore, a large portion of this set lies outside this set. That lies outside the domain of G. Therefore, it is not defined. Therefore, we should keep in mind the restriction when we try to compose FOG and GOF. So, next we try to come some examples. Okay. So let's take the concept of periodic function first. After we have now learned the type of functions, now let's discuss the periodic functions. What is periodic function? So periodic function means that if a function f satisfies this property, that f of x plus t is fx, where t should be a least positive number, then we can call that f is a periodic function. Like that, for example, like sin x is a periodic function with period 2 pi, because the phase actually matches after 2 pi. After 2 pi units in the if we go 2 pi unit in the right side or left side from any point, then the property matches. Actually, here it is upward direction, this is upward direction. Therefore, the period is 2 pi. So let's take some properties of the periodic function. If say fx has period t, then f of x plus c, x plus minus c into fx plus minus c, all these three things has period t. All these has period t. If we consider this transformation, like f of hx c into f of hx plus t, then its period will be t by mod of h. if we consider the addition of two different functions, let's say hx equals to f1x and f2x, then its period will be LCM of period of f1x and period of f2x if provided h is even function. And it will be half of LCM of period of f1x and f2x provided they are complementary function, provided f1 f2 are complementary function. So let's take an example for a clear vision. We will take two examples. Let's say hx equals to tan 3x plus sin x by 3. Then this has actually period 3 pi, and this is actually period pi by 3, and this is actually period 6 pi. Tan x has period period pi, and therefore tan 3x, I actually elaborating the states, has pi by 3. Sin x has period 2 pi, therefore sin x by 3 has period 2 pi into 3, that is 6 pi. So we have to take the LCM of 6 pi and pi by 3, and the rule of taking LCM of rational functions, rational numbers like this, is we have to take the LCM of the numerator and the HCF of the denominator, and this will be equals to 6 pi by 1, and this is actually equals to 6 pi. Now let's take another example for this case, when f1 and f2 are complementary function. So take the example of mod sin x and mod cos x. So we know that the graph of mod sin x is like this, and the graph of mod cos x is also similar to mod sin x, just a shift of pi by 2 in the x-axis. So their periods are pi. The periods are pi, and it has also period pi. So its period will be, so the period of hx will be half of LCM of period of f1 and f2x, half of LCM of pi and pi. This is pi by 2. So there are some other rules like that. If suppose that the period of some function is a irrational number, and if the period of some function is a rational number, then the period will be not defined. Suppose say that a function fx has period 2 pi and say gx has period half, then the period is actually not defined, because the LCM of irrational and rational are not defined, therefore it is not periodic. So these are the basic things that are actually included for the periodic function in wbjee syllabus. This is the end of my lecture on function. Thank you.